This is example 2 for the density practice problems. It states ethylene glycol, which is commonly found in automobile antifreeze, has a density of 1.1088 grams per cc. cc is an abbreviation for cubic centimeters or centimeters cubed. Remember, we can write it and state it in different ways. So whenever you hear cc, that's the units of volume, cubic centimeters, at room temp. What is the volume in cc of 1 kilogram of ethylene glycol? Okay, so in this problem, you are given the density and you are asked to find volume from a given mass. Okay, the mass that is given here is in kilograms. The mass that is given in the density is grams. It's important to recognize the units that are involved in your calculations because it helps you recognize the conversions that must be completed. So we want to find volume. What is the volume in cubic centimeters of 1 kilogram? We're going to use density as a conversion factor in order to convert between mass and volume, volume to mass, either or. So we are not using the density formula when we are solving for mass and volume. That's going to lead to some issues with algebra issues if you rearrange the formula incorrectly. So in order to save yourself from any algebraic errors, you can use density as a conversion factor. You are required to use density as a conversion factor when converting between mass and volume. So what we're going to recognize is that the density can be written as, I use purple here for a minute, 1.1088 grams over, this marker was working well. There we go, this one's the better one. .1088 grams of ethylene glycol, e.g. I'm going to abbreviate it, per 1 cubic centimeter of ethylene glycol. That's what the density means. The density is telling us that for every 1 cubic centimeter of ethylene glycol, it has a mass of 1.1088 grams. Okay. So now in our problem though, we are given a mass of 1 kilogram. So what do we know about the relationship between a kilogram and a gram? 1 kilogram is equal to 1,000 grams. So now using these two relationships, we'll be able to take our given value and change it to the desired unit, volume in cubic centimeters. So let's begin with our given value. 1.00 kilograms of our ethylene glycol. That's what we're starting with. We know that there is 1,000 grams in 1 kilogram. We need to change our kilograms to grams because our density has mass in grams. So 1 kilogram is equal to 1,000 grams. Cancel units diagonally. Then once we've gotten grams, we can use density as a conversion factor. Remember, a conversion factor can be flipped in whatever way that you need in order for you to cancel units appropriately. So this can be written in this format, or we can flip it, which is necessary here. In order for grams to cancel, we need to flip this fraction and put 1.10 0.88 grams per 1 cubic centimeter on the top. Cancel out your units of grams, and we'll be left with cubic centimeters, or cc, or centimeters cubed, whatever you like to call it. So now that we have our units all set up and correctly canceled, the next step is to use our calculator to solve the problem. So let's take 1 times 1,000 divide by 1.1088. This will give us an answer with a lot of numbers, but we need to round it for significant figures. So let me just write out the number that the calculator gives me. The calculator gave me this is what the calculator gave me. Now, based on our problem, we need to determine the least number of significant figures. This value is a measured value that has 3 significant figures. This value, 1,000 grams equals 1 kilogram, is an exact value. Exact values have infinite sig figs. So these we will not worry about. Here you have a measured value for the density. 1, 2, 3, 4, 5 significant figures. The least number of sig figs, so let's write this down first. So this was 3 sig figs. This was 5 sig figs. So therefore our final answer will be rounded to 3 significant figures, 902 cubic centimeters of our ethylene glycol.